In space, no one can hear you scream, or so I've heard. Space is empty of the stuff sound waves move through. In stuff, matter, like the air, sound is carried by waves of particles oscillating. Sounds are like a pattern in a group of things, rather than a thing in their own right. And in space, there are no things. At least that's the case now. In the distant past, things were different. Sound waves were responsible for this. And what is it? Each one of these orange pixels is a galaxy. Yeah, like the Milky Way. Sound waves in the early universe defined where these galaxies were created. Hang on, let me explain. Please comment, like and subscribe. It would be a huge boost for this channel. Thanks. In the early universe, before stars and galaxies were formed, huge sound waves echoed through the plasma that made up the universe. These sound waves, or acoustic oscillations, were carried in normal matter, baryonic matter, hence the term Baryonic Acoustic Oscillations, and its delicious acronym. These huge sound waves got baked into the structure of the universe, and today astronomers can see these huge bubbles, the wavefronts, in the patterns of galaxies in the largest scales of the universe. If it weren't for sound waves, the universe would look very different. Yeah, it's a bit complicated, so let's break it down. Sound needs a medium to travel through. At the current time, 13.7 billion years after the Big Bang, pretty much all matter is locked up into objects. Stars, planets, you, and so on. There are nebulas and interstellar dust, but these are extremely thin and tend to only reside in galaxies. Broadly, there are things, galaxies, made of stuff, and there is void, nothing, empty space. If we rewind the clock all the way back to just after the Big Bang, we would see that there was no such distinction. All space, if it can really be called that, was filled with stuff, plasma, in every direction with very little variance. Take a journey from here to infinity and the scenery doesn't change. Yawn. In this early universe, the plasma, or if we want to be really technical, and we do, baryonic matter, was evenly spread out, or nearly evenly. The Big Bang created stuff with small fluctuations in heat and density. The universe was nearly perfectly smooth, but there were small imperfections, areas that are overdense and areas of underdensity. Overdensity attracts matter toward it through gravity. Matter rushes in towards these dense areas, but matter isn't thrilled about this and resists being condensed, especially as it is so hot. As this matter resisted, it pushed back out in huge spherical pressure waves, echoing out from the central dense region. Remember, pressure waves are carried through matter. The matter itself is still, apart from when it wiggles carrying the wave. Think Mexican wave, not racers in a marathon. As the universe grew older, it expanded and cooled. As it cooled, it went from plasma to gas. Particles were suddenly far enough apart that they couldn't bump into each other. The waves stopped propagating. The areas of density were frozen in place. All across the universe, these spherical wave patterns were frozen in place. This gas coalesced into galaxies and stars, and the universe as we know it was born. And these spheres are big, dwarfing our galaxy. Today, on average, a bubble is 490 million light years across. If we took the average spacing of the galaxies in the universe, you would be able to fit 15,000 galaxies in one. But galaxies aren't evenly spaced. These frozen compression waves contain more matter, so more galaxies were born here. Looking out into the universe, astronomers can see these spherical patterns in the large-scale structure of the universe. The initial core of density surrounded by this 3D halo. These spheres overlap, as they were very common in the early universe. But teasing out the data from a plurality of galaxies, and these patterns become obvious. The patterns can tell us a huge amount about the large-scale structure of the universe. They are also a key to understanding the history of the universe. Scientists are using these bubbles to understand how the universe has evolved over time, including the nature of dark energy. But that's a story for another time. Please remember to like, comment and subscribe. You'd be doing this channel a huge favour. Thanks for watching.